Hello students, in today's class we will continue with the 13th chapter of our class 10th Science NCERT textbook. So here we will learn about electromagnet. Electromagnet is a substance which starts behaving as a magnet. So it is a substance which starts behaving as a magnet. But when does it behave as a magnet? When current is passed through it. But as current is switched off, magnetism is lost. So when current is passed through it, through a substance, that time it behaves as a magnet. But as the current is switched off, its magnetism gets lost. What does this electromagnet consist of? Means how it is made up of. It consists of a long copper wire. As you can see, the coil of insulated wire is there, which is wounded on soft iron core. There is an iron nail, and on that a coil of copper wire is done, and the ends of copper wire are connected to battery. You can see this coil, and the two ends of two coil are connected to the battery. This is the structure of electromagnet. Now there are some factors affecting strength of electromagnet. That is, there are number of turns in coil. In a coil there are number of turns, right? You can see in the figure given. The current is flowing in the coil. Whenever the current is passed, it flows in the coil, and there is length of gap between the two poles. Steel is not used for making electromagnet. Steel cannot be used as it does not loses its magnetism even if current is switched off. Why it cannot be used? Because it will not lose its magnetism when the current is switched off. That is, it forms permanent magnet. It has a permanent magnet. Then there is kicking wire experiment. The apparatus is set as shown in the figure. On pressing the switch, the current flows in wire. As you can see, there is a straight copper wire. So when the switch is on, when the battery is on, that time the current flows in the wire, through the wire in downward direction. As you can see, the current is flowing in downward direction as it is placed between poles of magnet. It is placed between the poles of magnet because force acts on it. The force will act on it, and the wire get displaced from its original position. The wire will get displaced. As you can see, there is a dotted line. That is the displacement of wire from its original position. So as it gets displaced, the circuit breaks and the current flow stops. As it will displace from the position, the circuit will break. So that's why current will also stop flowing, and due to which no force will act on the wire. No force will act, and it returns to its original position. And then again circuit gets completed. Then when the force will not act, that time it will come back to its original position. So that time the circuit will get completed, and again the force acts and wire get displaced. That time the force will act and the wire will get displaced, and this is how it goes on repeating. So this is the kicking experiment. Now comes Fleming's left hand rule. In the last class we studied about right hand rule. Here we'll study about left hand rule. What we will do? We'll stretch the forefinger, the center thumb and thumb mutually perpendicular to each other such that four fingers points in the direction of magnetic field. The four fingers will point in the direction of magnetic field. Center finger indicates direction of current. As you can see, it is clearly written in the figure. The forefinger points in the direction of magnetic field. The center finger indicates the direction of current, and thumb gives the direction of force of motion. Now comes the electric motor. Electric motor is a device which converts electrical energy into mechanical energy. Now the principle is, when rectangular coil carrying current is placed, when there is a rectangular coil carrying current it will be placed, that rectangular coil will be placed in the magnetic field. It is placed in the magnetic field. It will experience the force that rotate it. It will experience such a force that will rotate the rectangular coil. So there are B1 and B2 brushes, and the function of these brushes are to make contact with split rings. These rings are there. So it will make the contact with split rings, and the split rings commutator formed by splitting of copper ring. The split rings commutator is there, and it will be formed by splitting of copper ring. Function is to reverse the direction of current. It will reverse the direction of current. Working, if we see, imagine coil ABCD is in horizontal plane. There is a coil ABCD on a horizontal plane such that magnetic field is parallel to the plane of coil. So the magnetic field is parallel to the plane of coil. As you can see the green colored arrows. When electric current is passed through coil, when we pass the electric current through coil, that is from A to B, in segment AB, current flows from A to B. Current will flow from A to B, applying the Fleming's left hand rule, and we come to know that it experiences force in upward direction, that is C to D. So in segment CD, the current flows from C to D and force acts downward. That is Fleming's left hand rule. And the two forces being equal and opposite forms couple. The two forces which are equal and opposite, they form couple and rotate the coil in clockwise direction. So when the coil turns 90 degree, the commutator loses contact with brushes. The commutator will lose contact with brushes, and thus no force acts on the coil. No force will act on the coil, but due to momentum gained, the momentum that is gained, the coil continues rotating. The coil will continue rotating till it covers 180 degree. Till it covers 180 degree, till that the momentum that is gained, it will allow the coil to rotate continuously. And after 180 degree, the S1 connects with brush B2. S1 is there which connects with brush B2, and S2 connects with brush B1. And this alters the direction of current. This will alter the direction of current in coil, and new current flows in direction BADC, and new current will flow in the direction BADC, and this is how an electric motor works. Now comes the electromagnetic induction. This is most important topic. The production of electricity from magnetism is called electromagnetic induction. The electricity that is produced from magnetism, we call it as electromagnetic induction. Experiment, if we see, there is a wire AB is held between poles of magnet. Okay, wire is held, and two ends of wire are connected to galvanometer. There is a galvanometer, and the two ends of the wire are connected to it. Now, when wire is still no current is produced, but when wire is still, because no current is produced, means it is steady. When wire is in motion between poles of magnet, when wire comes in motion between the two poles of magnet, they cut the magnetic lines, and due to that the magnetic field strength will also change, and the current will be induced in the wire. So, electromagnetic induction can be defined as the production of current in a conductor. It is the production of current in the conductor when the conductor is moved between the poles of magnet, and the current produced, we call that current as induced current. Now comes Fleming's right hand rule. What you can do? You can stretch your forefinger, center finger and thumbs. mutually perpendicular to each other as we did for left hand, but in that there was Fleming's left hand rule. Here he will use his right hand. So we will keep it at such a way that forefinger points in direction of magnetic field, thumb points in the direction of motion, and center finger indicates the direction of induced current. Then comes the Lenz law. Lenz law states that in all cases of electromagnetic induction, the direction of induced current is such that it always opposes the cause that produces it. What does it state? That in all cases, whatever the case of electromagnetic induction is, the direction of induced current will be in such a manner that it will always oppose the cause that will produce it. For example, when north pole of magnet is approaching the end A, when the north pole of the magnet will approach end A of the coil, then direction of induced current is such that it opposes the motion of north pole towards A. It will oppose the motion of north pole towards A. Now comes AC generator. AC generator is a device which converts mechanical energy into electrical energy. So the principle of the generator is when conductor is moved in magnetic field, when we move the conductor in magnetic field, that time current is induced in the conductor. So how will it work? Imagine there is a coil ABCD in horizontal position. Now it is rotated in anti-clockwise direction between poles of magnet by rotating its shaft. What will be done? It is rotated in anti-clockwise direction between poles of magnet, and that will rotate its shaft. So when coil rotates, AB of coil moves down. When the coil starts rotating, the AB side of the coil will move down and it will cut the magnetic field lines of north pole. And CD moves up and it will cut the magnetic field lines of south pole, and due to which the induced current is produced. The induced current will be produced by applying Fleming's right hand rule. Direction of current will be B to A, that is VADC, B to A and B to C. Then current in the external circuit flows from brush V1 to B2, and after half rotation sides AB and CD will interchange. After there is half rotation, the sides AB and CD will interchange their position. So how AB will start moving upwards and CD will move downwards, and the induced current will be produced. So here the direction will be C to D, A to B, that is C, D, A, B. And external circuit current flows from B2 to B1. Then comes earthing. In electrical appliances are always touched by hands, right? So there can be a chance that its insulation breaks or cracks. Sometimes its insulation may break or it may crack down. So at that time what will happen? It bare fires touches its metal cases, and if we touch that metal case, then the person touching them might get a shock, and to avoid such metal cases are earthed. So that's why these metal cases are earthed. They are put deep in earth. So by earthing we mean that the metallic body is connected to thick copper wire. The metallic body is connected to thick copper wire, and this is buried deep under the earth. And at the end of the copper plate is surrounded by mixture of charcoal and common soil. So the earth is always at zero potential. So if an electrical appliance gets short circuit to the earth, like if magnitude of current rises due to short circuit, the fuse wire will melt. If due to the rise of current, the magnitude if the due to short circuit, if the magnitude of current will rise, that time the fuse wire will melt, but the appliance will not receive any current as it is earthen, as it is deep buried into the earth. So that's all for today. With this we complete our chapter number 13. If you have any doubts, you can ask. Thank you and have a great day.